Do you really think we need eco-friendly building materials in construction? As climate change accelerates and the need for sustainable living grows more urgent, the construction industry faces mounting pressure to rethink its heavy environmental footprint. Traditional building materials like concrete, steel, and insulation foam are energy-intensive to produce and contribute significantly to carbon emissions. But what if we could build homes using plants, specifically hemp? Enter hempcrete, a natural plant-based material that offers a compelling alternative to conventional building products. With its remarkable ability to sequester carbon, regulate temperature, moisture, and reduce the environmental impact of buildings. Hempcrete is gaining traction among architects, builders, and sustainability advocates around the world. This video explores what hempcrete is, how it's made, why it's considered eco-friendly, where it can be used, its limitations, and the key benefits that make it such an exciting option for the future of construction. Hempcrete, also known as hemp lime or bioconcrete, is a natural biocomposite material made from the woody inner core of the hemp plant called hurd or shiv, which is harvested and chopped into small pieces. It is then mixed with a binder made from lime and water to form a workable material, and used primarily as a lightweight insulating material for walls, floors, and roofs. Despite the name, hempcrete is not a replacement for structural concrete. It doesn't have the same compressive strength. Hempcrete is typically poured or packed into wooden formwork around a frame structure, where it gradually dries and hardens through a natural process called carbonation, absorbing carbon dioxide from the air as it cures. Unlike concrete, which sets quickly, hempcrete takes several weeks to fully cure. But once cured, it forms a solid, breathable, durable, and highly insulating envelope for buildings. Hempcrete is often considered a carbon-negative material, meaning it captures more carbon than it emits throughout its life cycle. Hemp plants absorb large amounts of carbon dioxide as they grow, and the lime binder continues to absorb carbon dioxide as the material cures. This double carbon capture process helps offset emissions from production and transportation. Because hemp grows extremely fast, maturing in just 3 to 4 months, and requires little water, fertilizer, or pesticides, it's a highly sustainable and renewable resource. It can be grown in a wide range of climates, improving soil health, and unlike trees, which take decades to grow, hemp can be harvested multiple times a year in some regions. Embodied energy refers to the total energy used to extract, process, manufacture, and transport a material. Hempcrete requires much less energy to produce than cement or steel, and the materials can often be sourced locally to reduce transportation emissions. Hempcrete isn't just sustainable, it also performs well in buildings, offering a range of physical and functional advantages. Hempcrete provides excellent insulation against temperature and sound. Its natural porosity slows down heat transfer and dampens sound waves, making buildings more energy efficient and quieter. Thanks to the lime binder, hempcrete is naturally resistant to fire, offering a high level of safety in residential and commercial structures. It doesn't burn easily and doesn't emit toxic fumes when exposed to high temperatures. Hempcrete is hygroscopic, meaning it absorbs and releases moisture to maintain a stable humidity level. This helps prevent mold, mildew, and rot, contributing to healthier indoor air quality. Unlike traditional wood and insulation, hempcrete is not appealing to termites, rodents, or insects, which reduces the risk of infestations and long-term maintenance issues. Despite its solid appearance, hempcrete is much lighter than concrete. This reduces the load on a building's foundation and makes construction easier and safer. Hempcrete is commonly used in wall infill systems for timber or steel frames, either poured on site or applied as preformed blocks or panels. It's also used in floor and roof insulation, retrofitting older buildings, and even in heritage preservation, where breathable, natural materials are needed to protect original structures. Its flexibility makes it ideal for eco-homes, small residential buildings, and even larger-scale commercial or community projects where sustainability is a priority. Its natural look and textured finish can also be left exposed for aesthetic purposes. Despite its advantages, hempcrete isn't without drawbacks. Because it's not load-bearing, it requires a separate frame structure. It also takes longer to dry than modern concrete, which can slow down construction timelines, especially in damp environments. In some regions, industrial hemp is still underused or restricted, and skilled labor familiar with hempcrete construction may be scarce. Some building codes and regulations don't yet recognize hempcrete, though this is changing as its popularity grows. Hempcrete is already being used widely in parts of Europe, especially in France and the United Kingdom, where it has been used in everything from small eco-homes to multi-story buildings, and even historic renovations. In North America, hempcrete is emerging as a green building solution, particularly in Canada and parts of the United States, where changing hemp regulations are opening up new opportunities for cultivation and use. In countries like Australia, India, and South Africa, interest is also rising as hemp becomes seen not just as an agricultural product, but as a critical piece of a circular economy. Hempcrete is just beginning to scratch the surface of its full potential. Innovations like precast hempcrete blocks and spray-applied hempcrete are making the material more accessible and construction-friendly. There's even exploration into 3D printed hempcrete, though still experimental, which could enable even more efficient and customizable designs. Combining hempcrete with other natural materials or synthetic additives to enhance performance and speed up drying times. In conclusion, hempcrete represents a smart, sustainable shift in how we think about building materials. Combining natural fibers, renewable agriculture, and low-impact manufacturing offers a practical way to reduce emissions, improve indoor air quality, and build for a healthier future. As awareness grows and building codes evolve, hempcrete has the potential to become a foundational part of green construction worldwide. Before you go, check out some of my other videos. Don't forget to hit the like button and subscribe. Thanks for watching. We'll see you at the next one.